Meanwhile, if in the meanwhile, if we require any basics, we'll start with that. Okay. So mainly two types of controls are there for this synchronous machine. One is separate control. Okay, one is separate control. The other one is self control. These are the two control methods for the synchronous machine. Okay. So now what is the self control? What is this separate control? Is that this is also called as open loop control. I mean, you don't take any kind of feedback from the from the speed or current. You don't take any kind of feedback. You just set yourself what is the
Sir,
yeah, please answer. Is it audible? Yes,
yes,
please.
audible.
Okay, so will see the block diagram of your separate control.
Sir,
Yes, please.
sir, in synchronous motors, speed remains constant, no, sir. Then which parameters we are trying to control, sir?
Frequency will try to control. Frequency is
Okay,
there. Okay, so when we change the frequency, this 120 f by p is there. So when we change the frequency, the speed n is equal to 120 f by p. So to change the speed of the synchronous motor, we change the frequency or we change the poles also. Okay.
yes, sir.
Okay.
That means we change from one speed to another speed and we rotate it there at constant speed, sir.
Yeah, it's something. Yeah, correct. It's correct that we means whenever you want to move to some other speed, then what you exactly do is that you change the frequency. Now here changing frequency also different. You follow V by F control here also. This V by F control is there. So V by F control in the sense we have discussed in the induction motor case where we have seen this thing that for example, if it is above rated speed, if it is above rated voltage, then in that case, so you recall this graph. I hope you remember this graph. This is the voltage and this is the frequency. Okay, so till rated values, voltage and frequency are proportional. So you want to reduce the frequency, you reduce the voltage also. But beyond that, you maintain the voltage constant. This is called V-wave control. So this principle you will use here. You will use the same principle here also. Okay, so you want to change, so because anyhow frequency is related to speed, so whenever you want to change the speed you have to change the frequency. But what is the precaution you will take is that when you change the frequency, do you change the voltage or do you maintain the voltage constant? It depends upon whether you are operating above rated values or below rated values. If it is below rated values, then voltage and frequency are directly proportional. If it is above rated values, you maintain the voltage constant. But the main logic here is that changing the frequency will change the speed here. That's the logic. You understand?
Yes, sir.
Okay. Okay. Now here, what do you find out here? This is L. This is C. Okay. So it's a separate control in the sense we can call it as separate control in the sense we can call it as open loop control. Why we are calling it as open loop control is that, see, we are not taking any kind of feedback anywhere. You see this. Directly we set a value of a reference, something we will set that value, okay, manually. Then this is delay circuit. So this circuit will delay your action. The action is the action in the sense you will set to some 60 Hz. You will set to some 30 Hz, something like that you set. Once you set here, this delay circuit is there. So actually, when you set in the sense, the response will be your action will be something like this, just a sudden jump. We don't want that kind of action. We want a delay so that the transients will not occur. So there is delay circuit is there. So the delay circuit will come here. Then that delay frequency will go directly to the voltage source inverter. So voltage source inverter will take this how much frequency you are setting. So that will take here, and then that same is going to some flux control. Then after the flux control, you have the reference voltage. You recall yourself there is a relationship between flux and the voltage, okay, and the frequency. This I explained even in the last class itself. That I will just recall that this graph, that you have this graph here voltage, and you have the graph here frequency. Then it will decide the voltage here. We Okay, who will decide? This flux control will decide the voltage. How we decide the voltage is it follows this graph. That it will think itself that whether the frequency is till the rated frequency or above the rated frequency. If it is above the rated frequency or if it is more than the rated values, then it will maintain the voltage constant. So this will give the answer. This flux control box will give the answer how much voltage V star should be. How much voltage V star should be. Okay, so that voltage, how much voltage it should be, it means which voltage it is. Let me tell you the voltage to your voltage source inverter. Remember now, the voltage of the inverter, because that voltage is going to your synchronous machines here. See, all the synchronous machines we connected in parallel, and for all the synchronous machines you are getting only one supply, that is from the voltage source inverter. So same voltage is going. So this voltage V will be decided here. Here it will decide. V star will be decided. What is V here? V is the voltage of the output voltage of the inverter or input voltage to your synchronous motors. So that voltage will be decided. So it will be decided based upon which parameter? It is decided based upon the parameter frequency. The frequency. How it decides this voltage here? Using this graph. Using this graph. You are increasing or you are decreasing or you are maintaining constant here. So based upon that, based upon this graph, is it above or below the rated values? Based upon that, you will decide V star. Then after that, you have the firing angle control. You know yourself that when you want to get this much voltage, what should be the voltage here? What should be the voltage here? So if you want to get this much voltage here, DC voltage, then what should be the firing angle? So in another words, this voltage V star signal will decide the firing angle, because this is the voltage you should get at the end of your inverter. So to get this voltage, what should be the value of alpha, so that this AC value will get rectified through this controlled converter. Then that controlled converter rectified voltage will come here. Then that voltage goes to your voltage source inverter. Then it generates this much voltage. So the alpha is decided by this voltage, or indirectly this voltage, or indirectly this voltage. Everything is related here. Okay, that's it. This is separate control. So whenever you want to change the speed, you change here. You change the frequency here. You set the frequency here. Based upon the frequencies you set here, based upon the frequency you set here, the voltage will be generated, and similarly the speed will change. Okay. So, and you see the same frequency signal. The same frequency signal is coming to your voltage source inverter. One side the voltage, the other. This is the frequency, whereas this side is voltage. Okay, so that is the values you need for this voltage source inverter. Then the output of voltage source inverter is going to your synchronous machine. So till this point, I told you already the flux is constant. I hope you can understand this thing. The flux is constant here. Okay. So separate control. Then we will go to self control. Okay. We'll go to self control now. Let me draw the block diagram. Block diagram. You give three phase AC here to the rectifier, control rectifier. Then after that, LC. So this rectified will be filtered, and you will get the pure DC here. Okay. Then this is inverter. This is inverter. Okay. Then it will go to the synchronous motor. The output of the inverter goes to the synchronous motor. Now you will take the feedback of a speed feedback. It is encoder. Then this speed feedback once again will go here. So there is a feedback here. You must understand now. Okay. In this case, there is a feedback. So it's a closed path. You can consider. This is a speed reference. So the reference speed, see here, the reference speed is there here. That reference speed will be decided by you. Then you see the previous one. Here you have the reference speed. Frequency is nothing but reference speed here. So this reference speed is going to your firing angle, okay, or directly going here. So this entire block we represented here with just one signal. This signal. The speed reference will decide what should be the value of alpha. The speed reference will decide what should be the value of alpha. In the sense, you see the previous block diagram. This one is deciding the alpha here. That's the total thing is combined into only one signal. Then after that you have the pulse DC here that when passed through L and C, you will get the pure DC. Then that DC goes to the inverter. Then you will get the AC voltage. Okay, now the speed you will just take as feedback. So then as for that, it will take action and it will correct that. So this entire block diagram we did not draw here. Just remember this thing that. Okay. So what you must understand here is that you must understand this thing that how it is controlling the speed. That's what you must understand. So all the blocks you know here already, what it does, and everything you know here. So I don't need to give more explanation here. So only thing is that it is a self control, whereas the previous one is the separate control. Okay. Of course, internally there are some more extra blocks are there that is not shown here actually. So now to understand about all these things, even about the synchronous motor. I told you already that we did not discuss the basics here, but if it is required, we'll discuss the basics. Okay. Now we'll see the numerical problem we will solve now, so that we may need some equations. Then we will just use that. A 5 megawatt star connected 6 pole 50 H 0.9 leading power factor synchronous motor has XS is equal to 10 ohm, RS is equal to 0 ohm. It means it is neglected. The rated field current is 50 ampere. The stator resistance is to be neglected. The machine is controlled by variable frequency control at constant V by F ratio up to base speed and constant V above base speed. Okay, determine first one the torque and the field current for the rated armature current of around 750 rpm and 0.8 power factor leading. Okay. Second question is that the armature current and power factor for half the rated motor torque for half the rated motor torque 1500 rpm 1500 rpm unrated field current. This is the question. So we'll go through the question first. Yeah, see here a 5 megawatt 3 phase 11 kV star connected 6 pole 50 head 0.9 leading power factor synchronous motor. He has given the data of the synchronous motor. XS is 10 ohm, RS is 0 ohm. Okay, so it is neglected. So the rated field current is 50 ampere. Okay, assume the stator resistance is to be neglected. That's what this is. RS is 0 already he has given the same statement he has given. The machine is controlled by variable frequency control at constant V by F ratio up to base speed and constant voltage above base speed. Yeah, this one, the same graph. This is V, this is F. Okay, this graph. Determine the torque and the field current for the rated armature current of 750 rpm and 0.8 power factor leading. That's the first question. Now, second question, the armature current and power factor for half the rated motor torque, 1500 rpm and rated field current, I think. Yeah. You see the first question, you have to find out the torque and the field current. Okay. Then we will do one thing. Okay. We'll always go ahead with the question. You have to find out the torque and field current. First, we'll see what is torque. So, what is torque? You recall the torque is, you have several formulae. One formula, I will write the basic formula P by omega. So, now what is P? P is the output power, omega is the angular frequency. So, what is the output power in the synchronous machine? So, we'll do one thing that we'll draw the equivalent circuit of the synchronous machine. I hope you can revise this. I suggest you revise this. For the time being, I will just add here. This is E, whereas this is V, and the current here is IS. This is XS. Now this is excited by a DC. You give the DC supply here. Okay, so this is the circuit diagram. This is the circuit diagram. So it is you generally take this as V at an angle 0, whereas you take this as V at an angle delta. I hope you can remember all these equations and all these circuit diagrams also. Okay, these are the basic circuit diagrams of the synchronous motor. Okay, so Yeah. Okay, so we can go ahead like this, but see there is a slight change is here. It is not delta, it is minus delta. Okay, it is minus delta. Okay, so is. So now you see what you need to understand is that what is the input power here? What is the input power here? So this is per phase circuit. So 3 VIS, 3 VIS cos theta. What is theta? Theta is the power factor. Okay. So that's the this is the input power. Now, as we have taken in the problem that the stator resistance is neglected, so there is no loss here. So whatever the input power, you will have the same output power. So I will write here P naught is equal to P naught. So input power, output power both are same because we consider the stator losses are zero because in the problem he has given stator resistance is neglected. Okay. Then once we got this P in is equal to 3 VIS cos theta, this is P naught here. Both are same. So we got P naught. So from this we can find out P naught. Okay, we'll go ahead. How to find out that? How to find out that power is equal to 3 into what is V? V is the phase voltage because it is 3 V phase 3 VI IS cos theta in the sense V you will take it as phase voltage. So what is the phase voltage? How do you find out the phase voltage here is the question. To find out the phase voltage, we see in the data, he has given 11 kilovolt star connected. So three phase. So it's a 11 kilovolts is the line voltage. So we'll write here VL is equal to 11 kV as it is star connected. So the phase voltage is 11 kV by root 3. Yeah, this is the phase voltage. And then IS, you have to find out the IS here. Next thing. Then we'll have the cos theta. So what is cos theta here? Cos theta, what is in the problem he has given? Theta also he has given in the problem. Okay. So we'll do one thing. That's at 6.887. Okay. So power factor, where is the power factor? See, he has given in the problem the power factor 0.8. So cos theta he has given. So cos theta value here I will write 0.8. Now only thing is that IS we have to find out what is IS so that we can get the value of power.
Sir, is
How
it 0.8 or 0.9, sir?
0.8 because you have to solve the problem for this. Okay.
Yes, sir.
Okay. So yeah. Then we'll do one thing. What we will do here is now see somewhere you will get that's the see the 0.9. I hope you understand. I understand why you are asking this because this is the rated values. All these are rated values of the motor, but you have to find out the problem here for these values for the 750 rpm and for 0.8 power factor leading and the armature current is rated. Okay, for these three cases you have to find out the problem. So that's the reason I put cos theta as 0.8. Then you have to find out the is value. Is value is this value. We have to find out now this value. What is this value? To find out this value, okay, we'll do one thing. There is clear.
Input power is 5 megawatts, you know, sir. They
Yeah,
have
that
given.
rated values he has given. That's the thing what I'm searching now. See, he said that it is rated armature current. So here IS is the armature current. You know very well. IS is the armature current. So and he said in the problem rated armature current. Then we will find out IS from the rated values. Yes, yes, whatever he said it is correct. He has given the rated power, rated voltage he has given. So then we will use the same formula once again. We will use the same formula P is equal to 3 VIS cos theta. But this time we will take all rated values. So what is the rated power? 5 megawatt. So 10 power 6. That is equal to 3 into. So what is the phase voltage? 11,000 by root 3. Okay. And then IS. That we will find out now. IS into what is cos theta this time? This time, as it is the rated values we are finding out, we will find out 0.9 here. We will take 0.9. So if we solve this, we'll get the value of IS. If we solve this, we'll get the value of IS. So what is the value of IS? We'll find out here. 5 megawatt. This is for This is 1.732 divided by 3 divided by 11 divided by 0.9. So 291.58. So here IS magnitude 291.58. This is IS magnitude. What is the phase angle then? Then how can I write the IS phasor here? Anyhow, I will write the IS phasor 291 point. Yeah, we generally take the voltage phase angle as 0. Then what is the current phase angle? Now he said it is leading. So leading in the sense current phase angle will be positive. But how much value it is if it is positive? He said 0.989 power factor leading. So theta is equal to cos inverse of 0.9. So that value will put here. Okay. 25.84. So the angle we got 25.84. So this is the rated current, a rated armature current. Now the question also he said it is rated armature current. So then we find out IS value here. We'll bring this here, this equation once again. Then we'll see P is equal to 3 into 11,000 by root 3 into 0.8 into 291.58. This is a magnitude. So we'll find out this how much it is. 291 point. Okay. Okay, what is the voltage we have taken here is I think we went wrong here. I'm sorry. Uh, there is a mistake here in this case. What is the voltage we have taken here? Okay, sorry for this. Yeah, this is the wrong one. This is a wrong take. We have taken it as wrong. Why did we take the voltage is 11,000 by root 3? Because we take it as phase voltage. But one thing you must understand, the torque he is asking at which speed? Of course, rated current is there, so you will get the rated current here. That's correct. But at a speed of how much? 750 RPM. That's important. Okay. So we have to find out at 750 RPM. Okay. So why we have to find out the 750 RPM? Why it is so? Why it is the relationship is there here? Is that yeah? This is wrong. It's not correct because we have taken directly the rated voltage, but that's not correct. Okay. There is a difference here. What is the difference is that see 750 RPM. I just told you already that what is the first of all what is the rated speed here? What is the rated speed here? 120 F by P. So we will take 120 F by P. A rated speed is how much? 120 50 by 6. So 1000 RPM. So this is the rated speed. This is the rated speed. But he is not asking at 1000 RPM. It's very important. He is asking at 750 RPM. There we went wrong. So 750 RPM in the sense he is reducing the speed. So when he is reducing the speed, how do you how anyone can reduce the speed in the synchronous motor? By reducing the frequency. So when you are reducing the frequency, do you maintain the same voltage that is 11,000 volts because 11,000 voltage is the rated voltage? Okay, so that's for the rated speed, that's for the rated speed and rated frequency. This 50 hertz it is 1000 rpm. For 1000 rpm we will use 11,000 by root 3. That we understood because at rated frequency rated speed is there, rated voltage. But now this speed is different. Now the speed here now becomes 750. So if, as the speed becomes 750, the question is that what should be the frequency to so that the what should be the frequency so that the speed is 750? Because how do you change the speed here? This I told you already in the very first statement of the synchronous motor that You will change the speed by changing the frequency. So now you see here, I want to get this speed, then what should be the frequency? Then 120 into f by 6 is equal to 750. Then what is f value? Okay, first we have to find out this frequency. Because the speed is different, so we should not get confused here. So 37.5. So the frequency now you will reduce to 37.5. So the frequency now you have reduced to 37.5 hertz. Okay. Now when you reduce the frequency, the question is that what do you do with the phase? What do you do with the supply voltage? Do you maintain 11 kilovolts or other than 11 kilovolts? It depends upon are you operating above the rated speed or below the rated speed. The rated speed is 1000 rpm. Now the question is at 750 rpm. So you are reducing the rated speed. So you are operating at below rated speed. When you operate at below rated speed, you have to follow V by F constant. This is what is the logic. So as you have to follow V by F constant, in the sense V is proportional to F. Now F is reduced to 37.5, so voltage also should be reduced to some value. What is that value? V1 by V2 is equal to F1 by F2. So from this V1 is how much now? 11,000 by root 3. This is 11,000 by root 3. V2 you have to find out. F1 is how much? F1 is a 50 hertz. What is F2? Just now we find out it is 37.5. Okay. So by doing all these things, we'll find out what is V2. Otherwise, we cannot take V2 here directly. So what is V2 here? If this is the case, I hope you understand this, that the question he is asking at 750 rpm. So as he is asking at 750 rpm, what is our job is that we have to find out what is the frequency at this. Why we have to find out the frequency is that there is a relationship between frequency and the voltage. So if the frequency is reduced, you have to reduce the voltage. If the frequency is more than the rated speed, you will maintain the voltage constant. This he has given in the problem directly. The machine is controlled by variable frequency control at constant V by F ratio up to base speed and constant voltage above base speed. So this he has given. So now as it is up to base speed, we will maintain V by F constant. So if you maintain V by F constant, so then what you find out is that V1 by V2 is equal to F1 by F2. So by substituting this, you will get the new voltage now. How much you have to supply? The new voltage, how much you have to supply, that you can find out. So 11,000. Yeah, triple four. I'm just cross checking once again. Nothing else is there. Yeah, we got different answers. So we should be very careful here while we take root 3. Okay, so you should take root 3, the entire root 3 you take. Don't restrict yourself to some value. Here also somewhere we got. So what is the answer we got here now? 4763.1. 4763.1. So this is the new voltage now, not the 11,000 by root 3. It's not correct. So you have to take. So here you will take the value 4763.1. Okay. Then here you will take here also 4763.1. So this voltage you will take now. So by taking this voltage, now this time we'll find out how much is the power now. We multiply with 3, we multiply with 0.8, 291 point. So now you got some answer here. So 3, okay, some lot of one thing that
Sir, we don't know IS.
we don't, we know IS 291.58. Here we find out IS. Yes, is it?
It's at 1000 RPM.
Yeah, it is 1000 rpm. But the question is that He said directly, we know we don't need to worry about the speed now. He said directly that at rated armature current. You see there.
Yes, sir.
So we will take that one directly, whichever he has given, we will take that one. Okay, so we cannot do anything in this regard because he has himself given the data that rated armature current. Then we will go ahead with that speed. Got it?
Yes, sir.
Okay, then 3333.2. So you got the answer 3333.2 kilowatt. So this is your power. We find out the power now, as of now. Then what is the torque now? What is the torque is now? Power divided by omega. So 3333.2 by omega. Omega in the sense, we'll have to find out omega now. How to find out omega now? Because omega we can find out using this formula, which one? 2 pi n by 60. So 2 pi n by 60. So omega is equal 2 pi n by 60. So 2 pi into 750 rpm by 60. So 2 pi n divided by 60. So you got some 78.54. Then we can find out the torque here. So now we got some answer here. See, it is kilowatt. You must not get here. So 42.43 kilo or 10, you put 10 power 3 into Newton meter. So 42.43 into 10 cube Newton meter. So this is the torque production. This is the torque production. Okay. So we got one answer now. So you see the first now. First
Sir,
thing, yeah, please.
కిలో ఎలా తీసుకున్నాం సార్?
See, this is kilowatt. Am I correct? You see the power here. This is
ఓకే
the
సార్.
power. It is kilo. So that's the reason I put here kilo also. Okay. Then we'll see the next part of the first question. Then you have to find out the field current. So how to find out the field current now? To find out the field current now, the field current has a relationship with the EMF. Okay, this you know, because this is DC. The field is DC in the synchronous motor. So this field current and this EMF induction has a relationship, just like your DC motor. Okay. Then we will take the help of that equation. Then we'll go ahead with that. Okay. So how we will proceed here is that in the question, I think he has given one question. He has given that a rated field current he has given. How much he has given? 50 ampere. Then we will do one thing. We'll find out here the EMF. What is the EMF? Applying KVL here in this circuit diagram. You see, we got some equation there. Yeah. V is equal to I E plus IS into XS. So then V is equal to E plus IS XS. Then from this we can find out E V minus IS XS. Okay. You'll find out this one by one. You will get so many values here. First, we'll find out for the rated values. We'll do one thing for the rated values. We'll find out. So if you find out for the rated values, then what is E? E is equal to what is voltage? So voltage will be, what is the voltage? The rated voltage 11,000 by root 3. This you will take at an angle 0 minus IS. We have find out that how much it is 291.58. 291.58 at an angle, because it's entirely phasors here. So at an angle 25.84. Why 25.84? Because the power factor is now leading 0.9. The rated value is 0.9. So if it is 0.9, then Yeah, you see here, directly we got this answer. So 291.58, 25.84. Yeah. Into excess. What is excess value? You see the question anywhere he has given excess value. Yeah, 10 ohm he has given excess value 10 ohm. Now it is reactance. So 10 at an angle 90 I will take as it is reactance. So solving this, you please solve this yourself using the calculator, then you will get this answer 8060.93 at an angle minus 18.99 ampere. So this is the answer you will get here. You cross check, maybe the calculation may be wrong, but you just follow this uh, relationship, then you will get the answer. Then after that, once we got this value, now there is a difference is here. What is the thing is that now the question is that he is asking the field current at which point at 750 rpm and zero point 0.8 leading power factor. Now whatever the EMF we find out, it is the rated value. So how to find out this thing is that to find out this thing, now we have already find out the voltage. There is a reduction in the voltage. V how much V now becomes somewhere we find out. While finding out the torque, we find out V. Yeah, we got the answer. You see here now, 4763.1. So 4763.1. It is an angle 0. This is the value of V. Okay, this is the value of V. Now, because we are finding out different values of speed and different values of power factor. So one more thing is that what is IS value? IS, he said in the problem IS is the rated value. So we have no other option other than we will take as it is 291.58. But what is the power factor we'll take is now this time it is 0.8 leading. So you will get the angle here 36.86. This you will get. And then excess value. What is excess value? Excess is equal 10 ohm he said. But this 10 ohm, whatever the 10 ohm he has given, it is for the rated frequency. But now the frequency becomes 37.5. So what is excess for 37.5? Then you multiply with 37.5 divided by 50. Okay. So you will get approximately 7.5 ohm. So this is excess value. So excess value is equal to 7.5 at an angle 90 degrees. So we got all the three. If you got all the three, then we can easily find out E. What is E here? E is equal to V minus IS excess. We can easily find out this thing. Then what is the answer you will get here is that 6321.9 at an angle. Yeah, you simply substitute all these values. I'm directly writing the answer. Minus 16 degrees. So this is the E value you get here. This is the E value you get here. Okay, now rated field current he has given. He has given rated field current in the problem. 50 ampere he has given. Okay. So now the question is that what is the rated EMF first of all? A rated EMF is how much? Somewhere you find out. Yeah, 8060.93. This is the rated field current. Now the question is the field current changes or is the EMF now? EMF changes with respect to the speed. This we know very well. So you'll find out this value. Okay, 8060.93 into 750 by 1000. Why I am doing like this is that the EMF has a relationship with the speed and just like your EMF induced in the DC machine, nothing else is there. 5Z by 60 into P by A. So this is the equation for the EMF induced in the DC motor. So similar kind of expression we can take here also. Then we simplify this 8060.93 to 750 divided by 1000. So 6045.69. Now what is this voltage? This is the rated, this is the EMF at this speed. This is the EMF at this speed, he said. Now we got an EMF value here at some other. So this is So at this EMF, what is the field current? 50 ampere. At this EMF, the field current is 50 ampere at this EMF. Now, what is the field current at this EMF? Because we have to find, so here is the question actually. We have to find out at this value. At this value, what is the field current he is asking? But he has given 50 ampere as the field current. So as he has given 50 ampere as the field current, there is a rated field current. So we will scale that rated field current to 750 rpm. Then we got this answer. So when we will consider that this is the EMF induced at this field current at 750 rpm, whereas this is the EMF at 750 rpm and 0.8 power factor leading. Okay, so then what is the actual field current now is that because E is proportional to phi, it means E is proportional to IF. We can take like this. Then from this we can easily find out 6045.69 divided by 50 is equal to 6321.9 IF. Now we have to find out this IF. That is the new field current. IF is how much IF is equal 6045 3 into 50. 52.28. So that is the new field current. That's it. So this is the field current we find out. This is the field current we find out. Okay. Okay. Now the next question is that what is the next question you see? Now you have to find out armature current and power factor for half the rated motor torque and 1500 rpm and rated field current. That's important. Okay. So better we'll bring this statement. So now you see here, what you will understand here is now speed he has given 1500 rpm. N is equal to 1500 rpm. It means you are increasing the speed above base speed. That's important. Then what is the frequency now you will get here? Frequency 120 f by p is okay. One 20. How much will get here? 750, 75 hertz. So the frequency will be increased to 750. So it is above rated frequency. So then I hope you can understand if it is above rated frequency. He has given in the problem that you maintain the voltage constant. That is, you maintain the voltage to be 11,000 by root 3. So just keep this point in your mind. So when frequency changes, your excess value also changes because it is directly proportional to your frequency. So your excess value now becomes 75 by 50 into 10. Okay, so it becomes something like this 15 ohm. This is new excess value. This is new excess value. Then what about the EMF? What about the EMF at this frequency and at rated field current? So 8060.93. So how we got this? We got this somewhere here. Just see this now. Yeah, here rated EMF. So you simplify this, then you will get 12,091.39 volts. Okay. So this you will get here. This you will get directly here. Okay. And then now what is the voltage here? What you must understand here is that what is the voltage here now? We have seen this thing that please see this now that when you are increasing the frequency above the rated value, you maintain the voltage constant. So this is your rated voltage. Once you got this rated voltage, now you will see the question. What he said now, You have to find out the armature current and power factor for half the rated motor torque. Okay. So for half the rated motor torque, so the torque now becomes half. Then we'll see now there is a relationship between torque and power. So T is equal to P into omega. 2 pi n T by, sorry, P by omega. I think so. Yeah. T is equal to P by omega. So he said that torque is half the rated one. So we'll do one thing, 1 by 2, 1 by 2 into T rated. Half, that is equal to P by omega. Okay. P by omega. So P by omega. So what is the omega here? Now you have to find out omega. So omega. Now recall omega. Omega is equal to 2 pi n by 60. This is omega. So one thing you will understand here. Now you have increased n to a value to 1500 rpm. So I will write this one as something like this. So 2 pi n by 60. Okay. I will write this thing that 2 pi into n 1500 rpm. So I will write first 1000, then 60. As n is 1500 rpm, so I will add this 1.5 at the end. There is no change now because n is 1500, so it becomes 1500. But the thing is that what is this value? This is the rated value because omega is 1000 is the rated value. So we'll write here. We'll write here. What we'll write here is that we'll write omega s into 1.5. What is P? What is omega s here? P is nothing but the rated power. Omega s is nothing but the rated angular frequency. So then, see, I'm not doing anything here. Oh, in place of omega, I'm writing 2 pi n by 60. N is 1500 rpm, but I'm writing 1500 as 1000 into 1.5. Why I'm doing like this is that you can take this 1000 outside, then it becomes 2 pi n by 60, where n here rated speed, and you multiply with 1.5. So P by omega, yes, P by omega. So P is rated, omega is also rated. That is the thing. So because of this reason, we are doing all these things. Then from this, what is P now? It becomes now. Okay. What is P now? Okay. So see, sorry, this is not rated one. This is the power. This is the new power. See here, once again, I will repeat this here to avoid confusion. This equation everyone know. T is equal to P by omega. Now he said you are reducing the torque by half. So torque becomes half, 1 by T rated. Now what will happen to the power? What will happen to the omega? We don't know what will happen to the P. We'll just P like that as it is. But we know what will happen to omega. What will happen to omega? Omega now you see here 2 pi n by 60 into, so n is equal to 1500 rpm. So out of 1500 rpm, we'll take 1.5 outside. Then this is a rated frequency. So I will write rated frequency. So this is rated. Yeah, better I will write like this. Then you multiply with 1.5. Then from this, what is P? New P. This is new P. So is equal to 1.5 by 2. So 0.75 into T rated, omega rated. So you are multiplying rated torque with rated omega. Then what you will get here? You will get rated power. P rated. Yeah, we can take like this. We can take like this. So the new power P is like this. The new power P is like this now. So why we need to find out all these things is that there is a reason that we need to find out the armature current first. So you recall how to find out the armature current. There is one equation. We have that V is equal to E plus IS XS. Okay. So there, from this we can find out IS. IS is equal. Now we'll do everything. We'll take it as phasors. V at an angle 0 minus E at an angle lambda divided by XS at an angle 90 degrees. This, just I'm finding out what is IS. V minus E by XS. That's, but in terms of phasors, I have written. So now in this, to find out armature current, what you require here, XS, he has given. XS, we can find out XS ourselves. Just now we find out it becomes 15. Somewhere you see 15. Yeah, this one, 15. Okay, this you got. Then V at an angle 0 also we got. How we got the V at an angle 0? Because you maintain the voltage constant for above rated frequency. So 11,000 by root 3. This also we know. So this no this. So what is E value now? E value, new E value also we find out somewhere. Just see this. Yeah, this one. 12,091.39 volts. And only thing which is left here is delta. This value we don't know. What is this value? To find out this value, there is an equation. I hope you may remember this equation. P is equal 3VE sine delta by XS. I hope everyone know this equation. From this equation, we can find out delta because everything is, So sine delta is equal to P into XS. What is P value just now we got? We got P value. The new P value we have to find out, not the old one. 0.75 rated. So 0.75 rated in the sense, so 0.75 into rated is 5 megawatts. So 5 into 10 power 6. Okay, into XS. XS value just now we find out it is 15 divided by 3 into V. What is V here? It's 11,000 divided by root 3. What is E we find out just now? Just now we got the value of E, that is 12,091.39. Everything we know except delta. So if you solve this, you will get the value of delta as 14.13. The value of delta. Why we need the value of delta here is that because we want in this equation, we want the stator current. So in the stator current we require. So now you substitute here. So 11,000 by root 3 at an angle 0 minus 12,091.39 at an angle 14.13 whole divided by XS. So XS value 15 at an angle 90. So solve this thing, then you will get the answer approximately 408.79 at an angle 118.77. Yes. This is the IS value. You solve this, then you will get the answer here. Okay, then what is the next question is what is the power factor? In that question, he said another bit is here. A power factor. How to find out the power factor? See, you got the value of here. You got the value of IS. IS value we got here. So VS minus IS. So then cos of 118.77. So you will get here 0.48. Of course, you will get a negative value. You take it as positive only. So this is the answer you got here. This is the power factor. See, only we need these equations. See here, one equation we got here directly, and this equation is the only equation which you might have got somewhere. Okay.